Smilodon fatalis, the most precisely engineered killing machine the Pleistocene ever produced. And for over 1 million years, it was completely, utterly dominant.
Imagine standing in Ice Age North America. Not the manicured suburbs and interstate highways we know, but a continent absolutely overflowing with life, at a scale we can barely conceive of today. Mammoths standing 12 feet at the shoulder, ground sloths weighing 4 tons, as heavy as a pickup truck, giant camels, short-faced bears that could look a modern grizzly dead in the eye and win. This was the Pleistocene, the age of megafauna, a world built on a scale that makes our own look small and timid by comparison. And into this world of giants, evolution unleashed its most sophisticated predator. Not the biggest, not the fastest, but the most precisely specialized killing machine that has ever walked on 4 legs. This is the story of Smilodon, where it came from, how it lived, what it could do that no predator before or since has ever matched, and why, after 1 million years of absolute dominance, it vanished almost overnight.
To understand Smilodon, you have to go back, way back, about 42 million years. Long before Smilodon, the cat family didn't exist. Instead, there was a group of predators called the nimravids, sometimes called false saber-tooths, that had already stumbled onto a brilliant idea: elongated canine teeth for puncturing prey larger than themselves. Evolution found this idea so useful, it invented it at least 4 separate times across completely different lineages. That is not coincidence. That is evolution arriving at the same conclusion through completely different paths. The saber-tooth design worked so well that nature kept reinventing it. In marsupials, in nimravids, in the true cat family, and in at least 1 other independent lineage. Smilodon's direct ancestors, the Machaerodontones, appear in the fossil record around 15 million years ago. Over millions of years, one branch of this family pushed the saber-tooth design to its absolute limit. The result was the most extreme predator the cat family has ever produced.
Here is something that surprises most people. Smilodon wasn't one animal. It was a genus, a family of 3 distinct species, each one progressively more extreme than the last. Smilodon gracilis was the earliest, appearing around 2.5 million years ago.
The size of a modern jaguar.
Fast, agile. Its fangs were impressive, but modest by what was coming. Smilodon fatalis, the deadly one, arrived next. Bigger, heavier, more muscular through the shoulders and chest than any cat alive today. Its fangs pushed 7 inches, and it is the species we know best because it died in enormous numbers in one extraordinary place. But the largest, Smilodon populator, the devastating Smilodon of South America, was something else entirely. At up to 880 pounds, it was heavier than a modern lion and tiger combined. Its canines could reach 11 inches. It may have been the largest cat, in the true sense of the word, that has ever existed.
When it bit down, scientists estimate the force was equivalent to a grown man hanging from those fangs by his full body weight. And here is where things get strange, because those fangs, for all their size, were not Smilodon's most dangerous feature. Now, those teeth. Every predator has teeth. Lions have teeth, wolves have teeth, but Smilodon's canines were something categorically different, and understanding how they actually worked tells you everything about how this animal hunted. A modern lion can open its jaw to about 65 degrees. Smilodon could open its jaw to 120 degrees, nearly straight down. It needed to. Those fangs were so long, they had to clear the lower jaw entirely before they could make contact with prey.
The canines themselves were not round like a lion's, designed to crush and hold. They were oval in cross-section, flat on one side, curved on the other, with serrations running along both edges, like a steak knife the length of your forearm, built out of bone. They were also, paradoxically, somewhat fragile. Smilodon could not afford to bite down on bone the way a modern big cat does. One wrong crunch on a femur, and a fang could shatter, likely a death sentence for an ambush predator that depended on those teeth above everything else. But here's the detail that changes everything. Those fangs also took longer to fully develop than a modern lion takes to reach full adulthood. Smilodon was investing years into its primary weapon. This tells us something critical about how Smilodon hunted, and we will get there. But first, the rest of the body.
Here is the curiosity that stumped paleontologists for over a century. Smilodon's body does not look like what you'd expect from the Ice Age's top predator. It had a short, bobbed tail, useless for the counterbalancing that helps a cheetah steer at 70 miles per hour. Its legs were shorter and stockier than a lion's. Its spine was less flexible. By any modern standard of big cat anatomy, it should have been a mediocre runner. And yet, it ruled a continent. The answer is in the shoulders and forelimbs. Smilodon was not built to run. It was built to hold. Its forelimbs were extraordinarily muscular. Some estimates suggest its grip strength exceeded that of any modern big cat by a significant margin. Its shoulder muscles were configured not for speed, but for wrenching large prey to the ground and holding it perfectly still while it delivered a killing bite. Think less sprinting cheetah. Think more professional wrestler. Smilodon never chased mammoths across miles of open ground. It didn't have to. It only needed one mistake. The question is, how did it manufacture that mistake?
As this chapter fades, another one is already stalking the horizon. A predator that didn't chase, it descended. Silent, precise, violent. One explosive vault and the sky belonged to it. One strike and the ground went quiet. The next video brings the apex shadow of the Cretaceous sky, Quetzalcoatlus northropy. Keep watching for the reveal, and subscribe to the channel so the moment it rises, the sky darkens for you first.
Everything about Smilodon's anatomy points to one hunting strategy: the ambush. It was not built to chase. It was built to wait. Modern research suggests that Smilodon may have behaved more like a leopard than a lion, using cover, patience, and explosive short-range acceleration to close the final yards. Studies of bone isotopes suggested preferred forest and woodland edges, where cover was available and prey passed predictably along established trails. It likely spent long periods completely motionless, not because it was lazy, but because patience was its most powerful weapon. Picture standing in Ice Age California at dawn. The grassland is still. A herd of horses grazes 200 yards away. Nothing moves in the tree line. And then something does. This is where the science gets genuinely remarkable, and where the popular image of Smilodon has been completely wrong for over a century. Despite the name saber-toothed tiger, Smilodon was not a tiger. It was not even closely related to tigers. Modern tigers are in the genus Panthera. Smilodon belongs to an entirely separate evolutionary branch that diverged from the true cat lineage millions of years before tigers existed. For decades, paleoartists also drew Smilodon plunging its fangs into the back of a prey's neck, like a giant vampire,
It looked dramatic. It was almost certainly incorrect. The problem is physics. Smilodon's fangs, driven straight down, would have required an almost perfectly positioned prey animal to make clean contact with the spine or skull. One wrong angle, and a fang hits bone and shatters. What the skeletal evidence actually suggests is something more sophisticated. Smilodon likely used its extraordinary forelimb strength, recall the wrestler's body plan, to wrestle large prey to the ground, controlling its head, exposing the throat.
Once the prey was immobilized, Smilodon would deliver a precisely targeted bite to the trachea and the major blood vessels of the neck. Not a crushing bite, a shearing bite. Those 7 inches of serrated bone sliding through soft tissue like twin blades. The prey didn't bleed out slowly. It died almost immediately. One successful bite to the throat, and the nervous system simply stopped. So what did Smilodon hunt? The short answer? Almost anything it wanted. Bone analysis and carbon isotope studies from Brea, the most complete record of Smilodon's diet we have, shows a diet dominated by horses and bison. Both large animals, both capable of killing a predator that makes a mistake. But the evidence also includes juvenile mammoths, giant ground sloth remains, and possibly even the occasional young glyptodont, essentially an armadillo the size of a Volkswagen Beetle. The mammoth question is the most fascinating. An adult Colombian mammoth, fully grown, was simply too large and too dangerous for a single Smilodon to take alone. But juveniles, old individuals, and animals separated from their herds during harsh winters, those were exactly the kind of prey an ambush specialist, with killing tools designed for large game, would target. If you were a mammoth calf, this was the last face you ever saw. And now, the question that has divided paleontologists for decades: did Smilodon hunt alone or in groups? Most large cats today are solitary. Lions are the exception, the only truly social big cat alive, and their group hunting allows them to take prey far larger than any individual could manage alone. The evidence from Brea tells a surprising story. The tar pits have yielded over 2,000 individual Smilodon specimens, and critically, a significant portion of those individuals show healed injuries, broken bones, damaged joints, injuries that would have been debilitating without assistance. A solitary predator with a broken leg starves. A social predator with a broken leg may be fed by its group while it recovers. This is not proof of pack behavior, but it is compelling evidence. And if Smilodon did hunt cooperatively, even occasionally, it would explain how it successfully took prey animals several times its own body weight. 2 or 3 Smilodon working in concert, using those forelimbs to control a mammoth calf, each delivering precise bites to different points. It is a terrifying image, and it may well have been real.
Smilodon was not alone at the top. The Pleistocene of North America was, by modern standards, almost absurdly well stocked with apex predators. And understanding Smilodon's place in that ecosystem tells us something important about how it survived and ultimately why it didn't. For over 1 million years, Smilodon had no natural enemy. No predator challenged it directly. No species competed with it on equal terms. Then, eventually, something appeared that did not fear claws or teeth. But we'll get to that. The American lion, Panthera atrox, was the largest true lion that has ever lived, bigger than today's African lion by a significant margin. It shared Smilodon's range. It competed for the same prey. Dire wolves, Aenocyon dirus, hunted in large packs across the same grasslands.
heavier than modern gray wolves with proportionally larger teeth. Relentless pursuit predators, exactly the opposite strategy from Smilodon's ambush.
And then there was Arctodus simus, the short-faced bear, possibly the largest terrestrial mammalian carnivore in North American history. Estimates put its weight at 2,500 pounds. Its legs were long and unusually straight. It may have been capable of speeds no modern bear can match. It was likely a kleptoparasite, a thief, capable of driving other predators off their kills by sheer intimidating presence. Even Smilodon, the most precisely engineered predator of its age, had to share this world. In the middle of what is now the city of Los Angeles, there is a place where time stopped. The La Brea tar pits. For at least 40,000 years, crude petroleum has seeped up through fissures in the ground here, pooling at the surface as thick, viscous asphalt. During the Pleistocene, this asphalt was often covered by water or leaf litter, invisible until an animal stepped into it.
The physics were brutal and simple. A hoof slips. Panic. The more it struggles, the deeper it sinks. Distress calls carry across the grassland. Predators arrive. Then the predators start screaming too. For tens of thousands of years, this trap operated continuously. Animals vanished here, one by one. Prey, then predator again. It was not a graveyard. It was a machine. The result is the most complete record of a Pleistocene ecosystem anywhere on Earth. Over 1 million individual specimens recovered, more than 600 species, all dated between 10,000 and 50,000 years ago, and among them, over 2,000 individual Smilodon. La Brea is, effectively, Smilodon's biography, written in bone and tar. There is one more remarkable detail about La Brea that almost no one talks about. At this site, predators outnumber prey in the fossil record. Think about what that means. The trap attracted so many scavengers and hunters responding to distress calls that the predators became the primary victims. A death trap disguised as a feeding opportunity for tens of thousands of years.
What the La Brea collection has revealed goes far beyond simple anatomy. Isotope analysis of Smilodon teeth, specifically the ratio of carbon and nitrogen isotopes locked into the enamel during development, tells us what individual animals ate during different seasons of their lives. We know that juveniles were weaned relatively late, suggesting extended maternal care. We know adult diet shifted with seasons, tracking prey abundance. The fangs themselves are a record of life history. Like tree rings, saber-toothed canines have growth layers that can be counted and measured. Smilodon likely reached full fang length at around 3 years of age. Full adult body size, perhaps 4 or 5 years. And then, the injuries. Smilodon individuals from La Brea show evidence of healed broken limbs, fused vertebrae from severe spinal arthritis, and joint pathologies consistent with repeated high-impact physical stress. Exactly what you'd expect from an animal that regularly wrestled large, dangerous prey to the ground.
Some of these individuals survived injuries that would have been immediately fatal without assistance. A Smilodon with 3 functional legs can still eat if something or someone brings food to it. Some of these animals should have died within days of their injuries. Instead, the bones healed, which means something kept them alive. The social implications are profound. Smilodon cubs were born, like all cats, completely dependent on their mother. But unlike modern big cats, where cubs begin accompanying their mother on hunts within a few months, Smilodon cubs faced a unique developmental challenge. Those iconic canines took years to fully develop. Longer, in fact, than a modern lion takes to reach full adulthood. Cubs were born with small, rounded baby teeth.
Adult canines would begin emerging around 18 months, but they remained fragile, functionally dangerous, but structurally vulnerable, until around 3 years of age. This means Smilodon mothers had to support their cubs through an extended dependency period, teaching not just hunting skills, but the precise, controlled bite mechanics that separated a successful kill from a shattered fang and a slow death. In a world full of American lions, dire wolves, and short-faced bears, keeping cubs alive for 3 years was an extraordinary investment. It required not just strength, but intelligence, memory, and the capacity to teach. A testament to how successful the Smilodon body plan was when it worked. Around 3 million years ago, one of the most consequential geological events in the history of life on Earth occurred in slow motion. The Isthmus of Panama closed. North and South America, separated for over 3 million years, were suddenly connected by a narrow land bridge. What followed, the Great American Biotic Interchange, was one of the most dramatic migration events in the fossil record. North American animals poured south. South American animals moved north. 2 completely separate evolutionary experiments, running in isolation for tens of millions of years, collided. Smilodon moved south. And what it found in South America was, in some ways, even more impressive than what it had left behind. Smilodon populator, the South American species, evolved in relative isolation into the largest saber-tooth that has ever lived. Its prey included giant ground sloths, toxodons the size of rhinoceroses, and Macrochenia, a bizarre camel-like creature with a flexible trunk-like snout. With less competition from other large felids, Smilodon grew even larger, even more extreme. It was the apex predator of 2 continents simultaneously. Of all Smilodon's competitors, none posed a more consistent daily challenge than the dire wolf. Aenocyon dirus was not as individually powerful as Smilodon. It could not bring down prey of the same size alone. But dire wolves compensated with numbers, pack sizes likely exceeding those of modern wolves. Here is an uncomfortable fact from the Brea record. Dire wolf remains outnumber Smilodon by a ratio of roughly 5 to 1. Far more dire wolves fell into the tar. This suggests they were more willing to take risks, moving aggressively toward distress calls, toward struggling prey, toward the trap itself. Smilodon, with its longer developmental period and harder-won individual hunting skills, appears to have been more cautious, more selective. Patience was Smilodon's greatest weapon. And in a landscape shared with pack hunters willing to die for a meal, knowing when to walk away may have been what kept it alive for a while.
And then, something new arrived in North America. Around 15,000 years ago, possibly earlier, the first humans crossed into the Americas from Asia, moving through Beringia during a period when sea levels were lower. These were not primitive people. They were highly skilled hunters, carrying sophisticated technology, atlatls, fluted projectile points, a deep knowledge of animal behavior, accumulated over thousands of years of pursuing megafauna in the Old World. And they were entering a continent where the prey animals had never seen a human being before, where every mammoth, every giant bison, every horse had no learned fear of the 2-legged thing carrying the stick, where Smilodon, the apex predator, the wrestler-bodied ambush specialist with 7-inch fangs, had no experience with the one kind of prey that could kill you from a distance without getting anywhere near your teeth. The clock had started.
Between approximately 13,000 and 10,000 years ago, Something happened in North America that has no parallel in the preceding 65 million years of mammalian evolution. In the space of perhaps 2,000 years, a geological blink, 35 genera of large mammals went extinct. The mammoths, the mastodons, the American horses, the giant ground sloths, the American camels, the short-faced bear, the dire wolf, and Smilodon. That world of giants from the Pleistocene that allowed this creature to exist simply ended. In the 10,000 years before this event, North America had been one of the most biologically diverse megafaunal communities on Earth. In the 10,000 years after, nearly all the large mammals were gone. What remained? Bison, elk, deer, pronghorn, were the smaller, faster, less specialized animals. The ecological collapse was total, and it happened almost simultaneously across 2 continents.
For over 60 years, paleontologists and archaeologists have debated what killed the megafauna, what killed Smilodon. And the debate, it is worth being honest about this, is not fully resolved. There are 2 primary hypotheses. Both have evidence. The truth is almost certainly both at once. The climate change hypothesis points to the end of the last glacial maximum. Around 12,000 years ago, temperatures rose rapidly, glaciers retreated, and the open grasslands that had sustained the megafauna began converting to forest. The dietary base of the large grazers shifted. Their ranges contracted, their populations fragmented. A predator like Smilodon specialized for large prey on open ground, with the wrestler's body plan built for ambush across grassland cover, would have felt this acutely.
The overkill hypothesis argues that newly arrived human hunters entering a continent of megafauna with no fear of people drove species to extinction through hunting pressure that these slow-reproducing animals could not sustain. The evidence is striking. Extinction events on continent after continent coincide with the arrival of humans. Australia, 46,000 years ago, when humans arrived, 90% of large mammals vanished. Madagascar, New Zealand, the Caribbean. Every time, the pattern is the same. Both forces were almost certainly operating simultaneously. Climate stress weakened the megafauna communities. Human hunting delivered the final blow, pushing species past the population thresholds from which they could recover. And Smilodon, a specialized predator with long developmental periods and the need to teach its young complex hunting skills, was precisely the kind of species that could not recover from that double blow.
Smilodon's story is a reminder that even the most perfectly engineered species can vanish when their world changes faster than evolution can answer. The last Smilodon died approximately 10,000 years ago. Maybe it was old, maybe injured, maybe slowly starving in a world where the horses and mammoths it had hunted for 1,000,000 years had already become rare. Their herds thinned, their ranges collapsed, the grasslands that hid Smilodon now giving way to forest. We will never know. We don't know where it died. We don't know if it was alone or if there were others nearby. We know only that at some point, on some unremarkable day on the North American plain, the last of its kind drew its last breath. And for the first time in over 1,000,000 years, there were no more saber-toothed calls across North America. The apex predator of the Ice Age, the culmination of 40 million years of saber-toothed evolution, was gone. Its bones sank into the tar. For 10,000 years, no human being knew it had existed until 1875, when workers excavating land in Los Angeles pulled up bones and teeth of creatures no living person had ever seen.
Here is what the loss of Smilodon actually means, not as a romantic tragedy, but as a scientific fact. The ecosystems we consider natural today, the African savanna, the boreal forest, the North American plains, are not natural. They are impoverished. They are the ecosystems that survived a mass extinction that we or our ancestors almost certainly helped cause. The lions and cheetahs and leopards we celebrate as the pinnacle of predatory evolution are, in a very real sense, the survivors. The ones small enough, fast enough, generalist enough to persist when the world they were built for disappeared. The California grizzly bear, depicted on the state flag of California to this day, went extinct in 1922. The last one was shot by a rancher. Smilodon, whose bones lie beneath the streets of Los Angeles by the thousands, is California's state fossil. Both are gone. Both are remembered. Neither is coming back.
But Smilodon's story is not finished. Modern analytical techniques are still yielding new discoveries from specimens collected decades ago. Ancient DNA work, recovering genetic material from Pleistocene specimens, is beginning to reveal details of Smilodon's biology that no amount of bone study could provide. Population structure, genetic diversity, possibly even something approaching coat color, inferred from the genes of close relatives. CT scanning has revealed the internal architecture of Smilodon's fangs, the precise arrangement of dentine layers, the blood vessel channels, the way stress was distributed through the tooth during a killing bite. From this, biomechanical models can simulate the actual force of the bite with unprecedented accuracy. What we knew about Smilodon in 1990 is a rough sketch. What we know now is beginning to approach a portrait.
And every new paper, every new specimen, every new analytical technique adds detail to an animal that lived and died before a single human being set foot on the American continent, before the first pyramid was built, before writing, before civilization. An animal that was apex predator of a continent for over 1 million years, and whose story we are only now beginning to fully read. The La Brea tar pits sit today in the middle of Hancock Park, surrounded by Wilshire Boulevard and 6 million people. School children visit on field trips. Tourists photograph the bubbling asphalt. Life-size sculptures of imperial mammoths stand at the edge of the lake.
Beneath their feet, and beneath the street, and beneath the foundations of the buildings, Smilodon. 2,000 individuals, their bones stained black by 1 million years of asphalt, their fangs as sharp now in the tar as the day they died. For 1 million years, this animal was the answer to the question every other creature on this continent was asking. And then the question changed. And the world changed faster than evolution could. Smilodon fatalis, the deadly one. A predator so precisely engineered for its world that it lasted 1 million years, and so precisely engineered for its world that when that world ended, it could not adapt. There was a lesson in that. There is always a lesson in that. One question worth sitting with. Could Smilodon have survived in today's world, given what we now know about its intelligence, its social behavior, its adaptability? Or was it simply too specialized, too committed to a world that no longer exists?
And as the last echoes of the saber-tooth fade, the world doesn't fall silent. Something else is already moving, not on the ground, but far above it. A shadow older than the Ice Age and far larger than anything left below.